Alright guys, what's going on? This is going to be your fall final exam review guide. Let's get started. With this problem right here, you first want to move -6 to, or subtract 6 to the other side. So minus x minus 6 is less than 0. Now we need to factor this. 2x plus 3, x minus 2. Alright, I'm just going to check it. 2x times x is 2x squared, minus 4x plus 3. That'll give me -1. Minus 6 is less than 0. And then I take both of these values and set them equal to 0 and solve them. And here I get x equals a -3/2. And here I get x equals 2. And so I'm going to go to my wiggle line test. And I'm going to find some values that I could test on both sides, on all three sides. So this is -1.5. So I'm going to test -2, 0, and 3. And I test my values in the original. Alright, so I'm going to do f of -2. So I'm going to plug -2 right here. So -2 squared is 4 times 2 is 8, and then that's a -2, which a negative becomes a positive, so 8 plus 2 is 10. Alright, so is 10 less than 6? No. So this won't work. So then I'm going to test f of 0. 0 squared is 0 times 2 is 0, minus 0. Alright, is 0, which is less than 6. So yes, this works. Yes, this works. And then right here, I need to test 3. So 3 squared is 9 times 2 is 18. Minus 3 is 15. Okay, so 15 less than 6 is not true. Alright, so this, no value greater than 2 works. So this is the column right here we want, guys. Also, let's open circle. Now, from a notation standpoint, I just want to talk through it. Alright, this tells me that x is greater than -3/2, but less than 2. Or you can see the interval notation -3/2. Open interval notation to 2. Alright, either one of these is acceptable. Okay. Now, I'm not gonna do this one so much. Alright, you can look at the answer key and see the solution here. But just to get you started, you will need to move everything on one side. So you will need to subtract 9x, and you will need to add 3 to this other side to have 2x squared. If you add 3, you get plus 4, and then minus 9x right there, or less than 0. Sorry. And then you'll factor this again. Ooh, I put 4x. That's just not 4. Sorry, y'all. It's just 4. Like that. Alright. Anyway. Then you'll factor this. You'll get something like 2x minus 1 and x minus 4. Like that. And then you get 2x minus 1 equals 0. X minus 4 equals 0. And then here you get x equals 1/2. Here you'll get x equals 4. I might as well do the whole thing. I had no intent on doing it. But anyway, 1/2 at 4. So you gotta pick values to check. So I'm gonna check 0. Nope, 0's here. I'm gonna check 0. I'm going to check 1. And I'll check 5. So f of 0. I'm going to check it right here in this one, right here, just because I can see it was less than 0. So 0 squared is 0, minus 0 plus 4 is 4. So 4 is less than 0, false. That's a no, right? And then f of 1. If I check 1, that's 1 squared is 1 times 2 is 2. And then you have minus 9 plus 4. So you get 2, 6. 6. 6 minus 9 is negative 3, which is less than 0. So yes. And then alpha 5. Alright, alpha 5, you plug it in, you get 25, 50, negative 45. 50 minus 45 is going to be 5. 5 plus 4 is 9. So 9 less than 0, no. So this doesn't work either. So we're right here. So how we will put that is, you could go 1/2 to 4 in open notation, or you could say 1/2 less than x less than 4 right there. So, or either one of these will work. Alright, for this one, the height of the population. Alright, the height H of 2/3 of the members of the population safety. Excuse me, satisfies the inequality. Man, I don't know what I'm talking about. But what we got here is, first of all, I want you to know that this is absolute values. So you have to have two versions. Alright, two versions. You have to have plus, a positive, and a negative. Okay? So I'm going to add to this negative 1. Alright? Now, let's go ahead and solve this thing where we have negative 1 is less than or equal to h minus 68.5 divided by 2.7. And then I have h minus 68.5 less than 2.7 less than or equal to 1. Alright, we'll do it like that. So, this will be my two versions. I'm going to solve both of these by starting by multiplying by 2.7 on both sides. Alright, so 2.7 times negative 1 is negative 2.7. Is less than or equal to h minus 68.5 all over. Oh no, it's not over 2.7 because I canceled that out. Now, add 68.5 to both sides. Alright, and what we get is 65.8. And then over here, multiply by 2.7 on both. On both sides. Sorry about that. So h minus 68.5 less than or equal to 2.7. And now 68.5 and h is going to be less than or equal to 71.2. So now that's our inequality right there. Alright, we have open interval notation 65.8. 71.2. Oh, brackets, by the way, I forgot. It's brackets because there's an equal to this time. Or interval notation 65.8 less than or equal to h less than or equal to 71.2. Alright. Okay. Now right here it says perform the indicated operation to simplify your answer. Well, I'm going to rewrite this one. 2 over x plus 2, x minus 2. I factor that denominator, x squared minus 4. Alright, so now you've got to ask yourself which denominator, or excuse me, what factor is missing from this other denominator on the right. Well, I'm missing x plus 4, so I'm going to multiply by x plus 4 at the top and the bottom. Okay. So that gives me 2 right here, 2 minus, this is a negative 1 right here. So negative 1 times x is negative x, and negative 1 times 4 is negative 4. Why did I write 4? I don't know why I did that, y'all. I'm so sorry. This should not be 4. This should be plus 2. I'm tired, I guess. So negative x minus 2. There we go. All over our common denominator. Now we simplify the top. 2 minus 2 is 0. So you just have negative x all over x plus 2, x minus 2. And there we go. Now, number 6, same type of expression. You need to factor first. So we have x plus 2, x minus 1, minus 1 all over x plus 2. Now, again, we need to get a common denominator at the bottom. So that gives me x minus, this is negative 1 times x is negative x, and negative 1 times positive 1 is going to be plus 1. And you'll see x minus x is 0. So there we go right there. 1 over x plus 2 x minus 1. Alright. Now let's look at, that's it for this one. Let's go right here. Okay, distance right here says 23, 24, find y equals, find y such that the distance between the points is 8. So here's the distance formula. x2 minus x1 squared plus y2 minus y1 squared. Okay, so for this one, we know what d is. It says d is 8. So you label 8 equals the square root of, and let me label this for you, x1, y1, x2, y2. Okay, so you have 3 minus 0 squared plus y minus 0 squared. And we simplify from there. 3 minus 0 is 3. And then reduce it from there. 9 plus y squared. Now, on both sides here, what we gotta do, what we gotta do here is square both sides to get rid of the radical. So 64 equals 9 plus y squared. And then I'm going to subtract 9 on both sides. So 55 equals y squared. And now to get rid of this square, we're going to square root both sides. When you square root both sides, you always inherit that plus or minus sign. So there we go. Y equals plus or minus the square root of 55. Alright. I'm going to leave that other one for you guys. Alright, now I'm going to go to 45. Right here. It says complete the square to write the equation of the circle standard form. Then use the graphing utility to graph the circle. Alright. What you're going to do is isolate the variables. Alright, I'm going to include a space here. And then y squared plus 6y plus a space equals 0. Oh, not equals 0. I'm going to subtract 6, move the constant to the other side. Now, what I got to do is I need to fill in these two blanks right here. Alright. So what I'm going to do is I'm going to use b divided by 2 squared. Alright, and b is just your standard a squared plus b squared c squared. Well, b right here is negative 2. So if I do negative 2 divided by 2 and square that, that's negative 1. Negative 1 squared is positive 1. I'm also going to add 1 on this side as well. Over here, b is 6. So 6 divided by 2 squared is 3. 3 squared is 9. Okay. And so now I add the right side. Negative 6 plus 1 is negative 5. Negative 5 plus 9 is 4. And then I need to factor this trinomial right here. And there's an easy tip right here. Alright, this is x squared, so it's going to be x squared. And then if you simplify this, negative 2 divided by 2 is negative 1. Negative 2 divided by 2 is negative 1. So x minus 1 squared right here, this is y squared, so y squared, and then look in the parentheses again, 6 divided by 2 is 3. So there we go, that's your equation right there, guys. I'm not going to graph it, but that's your equation. Alright, use a graphing utility to graph the function, then determine the domain range and domain and range of the function. So we need to graph this first real quick, so I'm going to graph it. So there's our graph right there. Alright, so you see right here that it doesn't start going to the left, it doesn't start going to the right. So we're going to say the domain is all real numbers. Domain is all real numbers. And now we got to look at the range. Over there. Alright, domain. All real numbers. Alright, or negative infinity to infinity. Alright, now range. Let's look at it. Alright, and we see that this is the lowest it's going to go, then it goes up from there. Right? The range, this is the lowest point. So we need to find that point right there. Alright, so how you do that is per second, then trace, then minimum. Alright, minimum because it's a concave up. That's a minimum. So click enter on the left bound and jump over to the right side, hit enter anywhere on the right side of that minimum. And then boom, there we go. Y is negative 2.125. So we're going to say the range is y greater than or equal to negative 2.125. Alright, or you can say negative 2.125 to infinity. That will be the range. Alright. Now this one here, notice that this is cubic. Alright, so the domain is all real numbers. And the range is all real numbers. That's because it's an odd degree. Alright. Okay, right here it says use the graph to find the limit. Alright, if it exists. So I wrote down a couple notes over here on the right. Just kind of talking about the limit as x approaches c. This is from both sides. This is from the left side. This is from the right side. Okay. So we'll look at this graph right here. It says, what is the limit as x approaches 0 of f of x? Well, let's look at as x approaches 0. So here's x is 0. So as it approaches from the left, it approaches 1. And as it approaches from the right side of the graph, it approaches 1. So we're going to say the limit is 1. Alright. If we say what is the limit as x approaches negative 1, you say from the left side it approaches 3. From the right side it approaches 3. So the limit is 3. Because it approaches the same limit from both sides, that's what you got to remember. Even right here, for example, alright, as x approaches 0. As it approaches 0, it approaches 1. As it approaches 0 from the right side, it approaches 1. So therefore, the limit is going to be 1. I know this is a whole, but that doesn't matter. It's what is it approaching, not what is it equal to right there. Alright, for this problem, describe the intervals on which the function is continuous. Explain why the function is continuous on the intervals. If the function has a discontinuity, identify the conditions of the continuity that are not satisfied. So for this first one right here, what we first need to do is factor. So x over x plus 1, x minus 1. Alright, now this, these are going to be vertical asymptotes. Alright, we take our denominator or denominators and set them equal to 0 or not equal to 0, because these values that we get will make this whole thing undefined. Okay, so think about it. Put negative 1 here. Negative 1 squared is 1. 1 minus 1 is 0. You cannot have x over 0. That's undefined. Okay, so that goes against the continuity. But those are points where it's discontinuous. Alright, so let's look at this next one. Oh, my fault. So we gotta define the continuity. That's my fault. So we're gonna say for continuous. Let me spell that. Oh my gosh, OUS. Alright, there we go. It's continuous from negative infinity to negative 1, union, negative 1 to 1, union, 1 to infinity. Alright, so that's where it's continuous. And again, it's discontinuous because these are vertical asymptotes. Now let's look at 18 real quick. Same type of problem. We're going to factor first. Alright, now see where this cancels? That's a whole. So we have a whole. So x equals 3. And then we have a vertical asymptote right here. Alright, so, negative 3, sorry. So where is this continuous? Well, it's continuous at all values, alright, except, and we just use the normal notation right here. So from negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. Alright, let's continue with it on those intervals. Alright. Now, let's look at the next question. The next question here says, in exercise 25 to 38, use the limit definition to find the derivative of the function. And the thing to remember is, you guys know how to find the derivative with like the power rule and etc. So I'm just going to write down the definition of limit right here for you. Alright, which is the limit as h goes to c, or you can say delta x goes to, h goes to 0, or you can say delta x goes to 0 as f of x minus h minus f of x all over h. So for this first example, it's a constant. Alright, we have a constant here. So we're going to evaluate it like this. We're going to say the limit as h goes to 0 of, this is our function 3, so we're going to say 3 plus h minus 3 all over h, right? So the 3's cancel, I'm left with h over h. And so if we plug in 0, we get 0. Alright, we know that the limit of a constant is 0, so it works out. But let's say we did, here I'll do this one. We got to do the limit as h goes to 0 of f of x. Well, I'm just going to plug in x plus h. So I'm going to go x plus h squared minus 4 minus x squared minus 4 all over h. So you got to expand this. X squared plus 2xh plus h minus 4 minus x squared. Oh wait, did I do that? Nope, I did not do that. So it's going to be minus x squared plus 4. So then we reduce x squared minus x squared, negative 4 and 4. So we have 2xh plus h. That should be h squared. Man, I tell you, it's late, I'm making mistakes. All over h. So again, I'm going to rewrite that because it was bad. And that's h squared. So you have 2xh plus h squared all over h. And then we're going to factor out of h. and now it cancels, so I'm left with 2x. I'm left with 2x plus h, and we're looking for the limit as h goes to 0. So I plug in a 0, and it's just 2x. And that's our limit. And now you know that's our limit because if I did the power rule, you would just do 2x, and that'd be 0. So 2x. Alright. If you know how to do the final limit with the power rule, guys, you'll be fine. Alright, so continuing with the same type deal here, guys. Alright, we're going to use definitions of limits as h goes to 0 of f of x plus h minus f of x all over h. So in this case right here, we got to find the tangent line. How to read the directions. We got to find the equation of the tangent line. So we first need to find the derivative using the definition of limits. So we have x plus h is going to go in place minus f of x all over h, and we expand this x plus h. Actually, I'm just going to expand that. So 1/2 x squared plus 2xh plus h squared, and then minus 1/2 x squared all over h, which we can simplify by distributing that negative 1/2 x squared plus xh plus 1/2 h squared minus 1/2 x squared all over h. And then if you look, 1/2 x squared will cancel with that, and so you have xh plus 1/2 h squared. Now you'll notice our h can cancel out. And so the limit here, as h goes to 0, it's going to be x plus 1/2 times 0, which equals x. And so, again, if you use a power rule, you'll see that 2 times 1/2 is 1x, so it's x. Now all we got to do is find m, right? So m is going to be f of 2, and we're going to plug it in right here. Alright, so f of 2 equals 2, there's m. Alright, I plug in 2. There's nothing to solve for, it's just 2. So then we use the slope intercept equation, y minus y1 equals m times x minus x1. X1 was 2, sorry. Come on, erase, my goodness. And then if you want to simplify it, you can add 2 over here. So you get 2x minus 4 plus 2. There you go right there if you want to simplify it. Alright, but I wouldn't trip. You can also leave it just like that. Not that 2 though. You can leave it just like that. Alright. Alright, you can do the other one. Alright, we got a few questions to answer right here. Alright, so the height s in feet at the time t in seconds of a silver dollar drop from the top of the Washington Monument is given by that equation, negative 16t squared plus 555. Find the average velocity on the intervals 2, 3. So remember, these are x values. That's x1, that's x2. So we need to first find the average. So to find the average, we need to find both y's. So for a, we need to plug in 2. 16 times 2 squared plus 555. Alright, and that's going to be a negative 1. And then we do s of 3. I'm sorry. That's not right. that's negative 64. And then we do S of 3, which is negative 16. Times 3 squared plus 555. And that's negative 144. So to find the average, we gotta do y2 minus y1 all over x2. So this is going to give us, that's a plus. Alright, and it's going to give us negative 80 over 1, which is negative 80 feet per second. So that's the average, that's part A. Now B says find the instantaneous velocity when t is 2 and when t is 3. So what I gotta do now is take the derivative. So s prime equals negative 32t. So negative 32, well here, let me keep my notation. So s prime of 2 would be negative 32 times 2, which is negative 64. And s prime of 3, because it's instantaneous, negative 96. Alright, now part C says how long did it take the dollar to hit the ground? Alright, so the ground is 0, right? So I'm gonna subtract 555 to both sides. So negative 555 equals negative 16t squared. And divide by negative 16. T squared equals negative 555 over 16, and now I'm just going to square root both sides. T equals 5.9. Alright, and then part D says find the velocity of the dollar when it hits the ground. So velocity again was s prime negative 32t. So if t is 5.9, negative 32 times 5.9 equals negative 188.8 feet per second. So there we go, there's D. Alright, you can do 18. Let's see here. Find the value of the derivative of Find the value of the derivative of the function at the given point state. Which differentiation rule will be used? So here, I would need to form this one. X squared negative 2 plus negative 4 plus 2 is negative 2x, and then negative 8. Alright, so then I'm going to take the derivative here. 2x minus 2. Alright, and so now I can find g prime of 4, which is 2 times 4 minus 2. That's 8 minus 2 is going to be 6. Alright, and then it says state which differential rule you use. So we multiply here. And then power rule. Alright. Let's see. That would be the same thing. So I'm not going to do that one. Let's look at this next one. That should be. I'll do this one. I guess we could do the quotient rule. Yeah, I do the quotient rule here. The quotient rule says we'll let this be f and this be g. So we'll go the derivative of f prime times g minus g prime times f all over g squared. So we can go, the derivative of f would be 4 times x squared minus 1 minus the derivative of this right here is 2x times all over x squared minus 1 squared. Alright, so then x is 0, so 4 times 0 squared minus 1 minus 2 times 0 . Let's see here, so 0 minus 1 is -1 times 4 is -4. 0 times this stuff is 0, so it doesn't matter. All over 0 minus 1 is -1. -1 squared is 1. So -4 over 1 is -4. There we go right there. Alright, let's see here. Find the third derivative. So first derivative is going to be 5x to the 4th minus 12x cubed. The second derivative is going to be 20x cubed minus 36x squared. The third derivative is 60x squared minus 72, sorry, shoot, 60, I'm writing 80, 60x squared minus 72x, there we go, third derivative. Alright, so I'm going to leave that one for you. Right here it says, find the given rule, so this one says find the second derivative. The second derivative, I'm gonna just write a little clearer on it for you. So I need to find the second derivative of g. So g prime is 20t cubed plus 20t, and I need to find the second derivative, which is 60t squared plus 20. So now we gotta evaluate for 2. So 60 times 2 squared plus 20, that's 4. That's 240 plus 20 is 260. Right there. I'll leave that one for you. That is the second derivative. Alright, I'm gonna do 16. Find dy over dx. Alright, so this is 3x squared minus 2y dy over dx equals 0. Okay. Now let's isolate dy over dx, and then we'll plug in after we isolate dy over dx. So minus 3x squared. So negative 2y. And then we're going to divide by negative 2y. So dy over dx equals negative cancels. So 3x squared all over 2y. And now we just got to plug in 1. Times 1 squared all over 2 times 1 equals 3 over 2. 3 over 2. Alright, right here, find the slope of the graph at the given point. So what's the given point? 1, 4, so there we go. For 25, we're going to do, let's derive this. So 6x minus 2 dy over dx plus 0 equals 0. So now subtract 6x. So negative 2 dy over dx equals negative 6x. And then divide by negative 2. So dy over dx equals 3x. And now all we gotta do is plug in our x value 1. So 3 times 1 equals 3. This is m. Alright, m is 3. Now, right here, it says the radius r of a circle is increasing at a rate of 3 inches per minute. So r prime equals dr over dt, which equals 3 inches per minute. Find the rates of changes in the area of A. R equals 6. And then we're going to do R equals 24. So we're going to do this twice. Now if you remember, A equals pi R squared. So right here, A prime equals 2 pi R times R prime, or you can say dr over dt. So we have A equals what am I thinking about? 2 pi R, which is 6 times 3. So in this case, 1236 pi inches squared per minute. And then if you want to do 24, it'd be 2 pi times 6 times 24, which is going to be, so 2 times 6 is 12 times 24 is 288 pi inches per minute. Alright, right here, just so you know, I put V. That should be volume. So V right here. Yeah. So there's the equation. You can work this one out. Just to help you label your parts, R prime is 3 inches per minute. And then you gotta do it twice. You gotta file the first R when R is 6, and then the second R when it's 24. So you work that out, file the volume. This is also dr over dt. Find the equation of the tangent line to the graph of the function at the given point. So we got to derive everything with respect to x of dy over dx equals y prime. This is going to require the product rule. Alright, we actually did this product in class. So you have 20x, and then the product rule right here is going to give us the derivative of 4x is, negative, 4x is negative, is 4 times y, alright, plus, and then the derivative of y is dy over dx times 4x. And then we continue right here, the derivative of 2y squared is 4y dy over dx. And then minus 0, the derivative of 16 is 0, equals 0. So now I just need to simplify all this. 20x minus 4y minus 4x dy over dx plus 4y dy over dx equals 0. So we're going to subtract 20x, and we're also going to add 4y to the other side. So that gives us negative 4x dy over dx plus 4y dy over dx equals negative 20x plus 4y. And so we're going to factor out a dy over dx. And then we'll divide negative 4x plus 4y on both sides. So dy over dx equals negative 20x plus 4y all over negative 4x plus 4y. And then since we got to find the tangent line, I'm just going to plug in 1. So I plug in, or I got to find m. So dy over dx, in this case for m, equals negative 20 times 1 plus, I need to plug in y, 2y is negative 1. So 4 times negative 1 all over negative 4 times 1 plus 4 times negative 1. So that's negative 20 minus 4. And that's negative 4 minus 4, which equals 3. This is m. So y minus, or in this case plus y1 equals m times x minus 1. There's our equation of our tangent line right there. And now we have one more equation. Alright, so for this one, I'm going to rewrite it. And before I even do that, I need to find y. So to find y, I'm going to plug in 3. So 3 squared is 9 times 2 is 18. 18 minus 2 is 16. So the square root of 16 equals 4. So y equals 4. Alright, now I need to do u substitution. So u equals 2x squared minus 2. And f of u equals u to the 1/2. So u prime equals 4x. And f prime of u equals 1/2 u to the negative 1/2. So we end up with y prime equals 4x times 1/2 u to the negative 1/2. So now I gotta plug in x to find. So 4 times 3 times 1/2 times 2 times 3 squared minus 2. All raised to the negative 1/2. And you can literally punch this in your calculator and let it work for you. So I literally put it in the calculator, guys. Alright, 4 times 3 times 1/2 times 2 times 3 squared minus 2 raised to the negative 1/2. And I got 1.5 over 3 halves. So m equals 3 halves. Alright. So now the tangent line would be y minus y1 equals m times x minus x1, like that. And that would be it. Now I know this got long. I'm sorry, but I hope it helps. And good luck on your final exams. Catch you later.